This is part 2 of our sessions on how we forecast using moving averages. Now in part 1 we looked at how to forecast data using moving averages, and by using moving averages we were able to calculate trends and also seasonal variations in data. The illustration that we used in part 1 was based around a 5-day working week, and the methods that we used in part 1 are going to work for any period that's based around an odd number, so whether that's a 5-day week, a 7-day week, or whatever. But there's going to be a problem where we have data for periods containing an even number, and we see this type of situation cropping up quite commonly, because we have 4 quarters in a year, 12 months in a year, you might have a business that's working 6 days a week. So we're going to have a look at the problem that's being caused and how we can solve it. So let's have a look at an example. A company wants to forecast its customer numbers for the future. So it's analysed its past customer numbers on a quarterly basis, and these are shown in our table to the right. So we've got details for 2011, 2012 and 2013 for each quarter in those years. Now, as there are 4 quarters in a year, it makes sense to calculate our moving averages using a 4 periods or 4 quarters. So we can calculate those as we have done before. But what you'll notice is that the 4-quarter moving average that we've calculated doesn't line up exactly with a particular quarter. It's in the middle. It's positioned in the middle of quarters 2 and 3. And this is something of a problem. So we can calculate the rest of the 4-quarter moving averages, and we could look at that and establish what a trend for the data, but we're going to have difficulties in calculating seasonal variations. So this is the problem that we have to address. Now what we can do is we can then calculate another moving average, but this time based on 2 rather than 4 values. So we start with the 4-quarter moving averages, and then we'll add on an additional column. And in this column we're going to calculate an additional set of moving averages, which are this time based on the 4-quarter moving averages. So my first 2 pieces of data, I end up with a moving average of £60,000, and I can calculate my moving averages for the rest of the table as well. What you will notice is that now I have a moving average that does line up with a particular quarter in the data. So I'm now able to calculate seasonal variations. Now looking at this data, I can establish that the moving average is increasing at £5,000 each quarter, and we can now look at what the seasonal variations are going to be. So the seasonal variations are going to be calculated by looking at the customer numbers, the actual customer numbers, and then deducting that second column of moving averages from the corresponding quarter. So we'll calculate the seasonal variations as we did before. So 120,000 less 60,000 gives me a seasonal variation for quarter 3 of 60,000. And I can calculate the other seasonal variations for this data as well. So for quarter 1 I have a seasonal variation of minus 20,000, for quarter 2 minus 10,000, quarter 3 plus 60,000, and quarter 4 minus 30,000. I now have both the trend and the seasonal variations, so I'm in a position where I can prepare forecasts based on the information that I have. And that's how we deal with situations where I have an even number of periods